Welcome to Math is Fun with Amajoy. Welcome to today's lesson, Algebra Lesson 4. I hope you're staying safe and I hope you have been practicing. For today's lesson, multiplication and division of algebraic expression, I'll be introducing you to exponentiation or theation, anyhow you pronounce it, in mathematics. So this is an interesting topic. It's more of indices and exponents. It's so interesting. So interesting. So grab your book and your pen and let's get working. Okay, exponentiation. Exponentiation is a mathematical operation written as a raised to the power n. So this here is a raised to the power n, where a is the base and n, which is small n, means either the exponent, power, or index. So we can call this n here. We can call the n there the exponent or the power or index. So the plural for index is what we know as indices. So beginning of this lesson, I talked about indices and exponents. So it's either we call it an index or an exponent or a power. So that's why we pronounce this as a raised to the power n or a exponent n or a index n, whichever one. Okay, so in order to solve indices or exponents or anything containing indices and exponents, we would have to apply the rules of indices and exponents. Okay, so for our lesson, I've narrowed the rules down to 5. There are far more rules than this, but the understanding of this will help you understand those ones in future. So the first rule says that a raised to the power m times a raised to the power n is equal to a raised to the power n plus n. So we'll go further into details on all this. Then the second one says a raised to the power m, all that into brackets, bracket close, times, so that times, bracket means multiplication, times raised to the power n. So this m and n are on the same level. So with that, we'll be having a times mn. So the third rule says a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. So when the two exponents are dividing, we subtract the exponent. Or when the two bases are dividing, we subtract the exponent. The fourth rule says that a raised to the power 0 should give us 1. The fifth rule says a raised to the power negative 1 is equal to 1 over a, which is also a raised to the power minus m is equal to 1 over a raised to the power m. So whichever way it appears. Okay, so now let's go into details with this rule one after the other. So for the first rule, suppose we have a raised to the power 3 and we want to multiply by a raised to the power 2. That is a raised to the power 3 here times a raised to the power 2. This is the same as this a raised to the power 3 here is the same as a times a times a, like your factorization and all that. So a raised to the power 3 means we are multiplying a 3 times, and a raised to the power 2 means we are multiplying a repeatedly. So we have a times a to give us a2. So this is a3. and this is A2. Okay, so we are using A to explain to you that the bases must be the same. So A raised to the power 3 times A raised to the power 2. A is here, A is here. So meaning the bases are the same. So we have A and A. So A raised to the power 3, A raised to the power 2. So it can be 2 raised to the power 3 times 2 raised to the power 2. The two bases are the same. We know what the base is. Base A is base. A is base. 2 is base. So if I have 2 raised to the power 3, 2 raised to the power 3 times 2 raised to the power 2. The bases are equal. I repeat, these rules apply to only cases or examples where the bases are the same. So unless this is A and this is A, that is the only way this rule can be applied. But if it's A raised to the power 3 times B raised to the power 2, the rule can't be applied. We'll just leave the answer like that. We'll leave the answer like that. So if we have A raised to the power 3 times A raised to the power 2, this gives us A times A times A times A times A times A. So we can simply count this A. So we can simply count. So we have 1A here, 1A here, 1A here. So we want to count the number of A's we have. So that's 1, 2, 3, 4, 5. So our answer can be A raised to the power 5. A raised to the power 5. This is one way of finding the answer. But don't forget, yeah, they said that this is what we are talking about. They said you should maintain one of the A's and add the exponent. So that's a simpler way to solve. If you have something like A raised to the power 15 times A raised to the power 10, it's too long for us to start counting 15 A's and 10 A's and adding everything together. So the easiest way is to just maintain one of the A, then add 10 plus 15 to give us 25. So we'll apply the same thing here. That's the easiest way of solving this. So we'll just take one of the A's, which is this, take the exponent, this, and then add them because they are multiplying. Because they are multiplying, we add. Fine. Now let's go to the second rule. Second rule says, suppose we had A raised to the power 4 and we want to raise it all to the power 3. That is, so I have my A raised to the power 4 there, but then I want to make it this whole A raised to the power 4. This whole A raised to the power 4. I want to raise it to the power 3. So that's why I put it in a bracket. So this A raised to the power 4 in a bracket 3. Yes. So if I have something like this, we take A raised to the power 4 as a single entity. So A raised to the power 4 is one thing. So A raised to the power 4 raised to the power 3 will now give us A raised to the power 4 3 times. So that's why we separate it here. A raised to the power 4, A raised to the power 4, A raised to the power 4. So A raised to the power 4 3 times. So in this case, our first rule is not going to apply here. Although they are multiplying, but note one thing. This A raised to the power 4 bracket 3 is different from A raised to the power 4 times A raised to the power 3. So there are two different things. So this is different from this. So we can't apply the first rule to this. There are two different things. So in this case, what we do is, since the exponents are the ones multiplying, we'll multiply the exponent. So this 3 is also an exponent or a power. So this power will multiply this power. So power meets power, not power meets base. So in this case, the 3 has no business with the A. So it's just a 4. They are dealing together. We don't add, we multiply. So A raised to the power 4 becomes times raised to the power 3 becomes a raised to the power 4, the 4 times 3. So in this case, we get 12. We get 12. Or simply put, like what this has done, it means a raised to the power 4 3 times. So we have first a raised to the power 4 here, second one, and third one, because it says a raised to the power 4 3 times, right? So since we have this here now, then we can decide to add the exponent. So 4 plus 4 plus 4 will give us a raised to the power 12. So if we don't want to use this method, we'll then have to use this method of we multiplying just the exponent. So we get 4 times 3. So this is a simpler way of solving it. So in simple terms, if we have a raised to the power, if we have a raised to the power m times n, this will give us a raised to the power mn, because m times this n here will give us mn. So that's why we have this on the screen. Okay, so let's see the third rule. So for the third rule, it is the opposite of the first rule. The first rule says if we are multiplying, we add, but if we are dividing, we subtract. If we are dividing, we subtract. So consider dividing a raised to the power 7 by a raised to the power 3. So we have a raised to the power 7 divided by a raised to the power 3, which is a raised to the power 7 over a raised to the power 3. So alternatively, we can solve it by expanding the a raised to the power 7. So we would have a 7 times and would have a 3 times. So in this case, we have 3 a's down here, right? So in division, division of factors, this a can cancel this a. This a can also cancel this a. And this a can also cancel this a. Yes, alternatively, and would have how many left? 1, 2, 3, 4 a's. So the answer will be a raised to the power 4. Alternatively, we can solve it this way. But following the rule, if we are dividing, we subtract. So we'll just subtract the exponents, maintain one of the a as we did for the multiplication. Then we subtract the exponents, which is 7 and 3, to give us 4. Simple as that. Mathematics is the sweetest subject you can ever get. So a raised to the power 7 minus 3 will give us a raised to the power 4. So would maintain one of the a's and then subtract the exponent. As simple as that. So these rules and laws should be on your fingertips. You should be able to apply them as the questions come. Okay, so let's see the fourth rule. Let's have a look at a raised to the power 3 divided by a raised to the power 3. So now the exponents are the same. We know the answer to this. We are dividing the quantity by itself, so the answer has got to be 1, right? Yes. Because a raised to the power 3 is the same as a raised to the power 3. So I used to make this joke. You yourself divided by you yourself is 1. Anything divided by itself is 1. But now, let's do this using our rule. Rule 3 would help us understand this. So in a case where we have to apply the rule, so the same thing, we are using the rule, which is rule 3, the division would subtract the exponent. We will get a raised to the power 3 minus 3, which is a raised to the power 0. This is supposed to be our answer and not this, right? Because here we got a 1, but now we are getting a raised to the power 0. So now in the fourth rule, Okay, we appear to have obtained a different answer. We have done the same calculation in two different ways. In mathematics, you can use diverse ways of solving a particular problem, and when you do so, you would arrive at the same answer because mathematics is dynamic. But in this case, we are getting a different answer, but we've done it correctly in two different ways. So the answers we get, even if they look different, must be the same. So therefore, this is how they came up with the fourth rule that anything raised to the power 0 is 1. This is how the fourth rule appeared. So from here, we said the fourth rule says a raised to the power 0 should be 1. So me myself raised to the power 0, I am 1. So anything raised to the power 0 is 1. So 2 raised to the power 0 is 1. 1 million raised to the power 0 is 1. 1 over 2 raised to the power 0 is 1. Negative 6 raised to the power 0 is 1. Anything raised to the power 0 is 1. Fourth rule. Okay. Now on to the fifth rule. Let's have a look now at doing a division again. So let's see what the fifth rule told us. The fifth rule says a raised to the power negative 1 is the same as 1 over a. A raised to the power minus m is the same as 1 over a raised to the power m. So what is missing here? When we did the conversion, the negative signs are gone. Negative signs are gone, and then a fraction has been introduced. So this applies to where we have a negative exponent. We can't solve with a negative exponent. Well, I know you can solve some questions with a negative exponent, but in some cases you would have to change them. So this rule is very important. I didn't want to include it for our level. I wanted to leave it for later on, but the knowledge of this is helpful. You can boast with it that you understand this. So the fifth rule, let's consider dividing a raised to the power 3 by a raised to the power 7, as we've done before. Okay, but this is the inverse of what we did before. So now we have 3a's up and 7 down. So this is a proper fraction in this case. So we are supposed to get 1 over, because this 3a's will cancel 3a's here, and we'll be left with 4a's. Fine. So we would be having 1 over a raised to the power 4. Now let's use this third rule, our third rule, to do the same calculations. If we use our third rule to do the same calculation, don't forget the third rule says we should divide. When we are dividing the exponents, we should subtract. When we are dividing bases, we should subtract the exponent. So if we are using the third rule here, this is what we should get. A raised to the power negative 4. The same question, two different methods, but two different answers. So from this was how the fifth rule came into being. The fifth rule is now telling us that if we have any number raised to the power a negative exponent, just find the inverse. Don't forget, anything standing alone has a hidden 1 beneath it. Everything is over 1. I am over 1. You are over 1. So anything standing alone has a 1 under it. So this a exponent minus 4 is the same as a exponent minus 4 over the hidden 1 here. So since we have this, we want to get rid of the negative sign. So all what we need to do is to just find the reciprocal. So it's called finding the inverse. So meaning the 1 will come up and the a raised to the power negative 4 will come down. But now the negative will vanish and then the 4 comes. So because the negative vanished, that was why we had our a positive 4 now. So the negative has vanished, and now we are having 1 over a raised to the power positive 4. So we've done the same calculation. So with this, that was how this fifth rule was invented. So 1 over a raised to the power 4 is the same as a raised to the power negative 4. So we can do the opposite. So if I have, let's say, 1 over 2 raised to the power x, this is the same as 2 raised to the power negative x. If I have 3 minus y, rewriting this will be 1 over 3 raised to the power y. Okay. So examples are here. 2 raised to the power negative 2. This is the same as finding the reciprocal. You get 1 over 2 raised to the power 2. The negative sign disappears. So we'll be having 2 raised to the power 2 is the same as 4. That's 1 over 4 as our final answer. 5 raised to the power negative 1 is the same as 1 over 5 raised to the power 1. So the 1 will disappear. 1 I told you was really... Okay, I've not told you this. I told you about the positive signs, that any number standing alone without saying otherwise, less than negative, it has a hidden positive. So there's a positive beside it, and one thing you should note too is, for example, if I have a standing alone just like that, there is a 1 year, right? There's a 1 year. Sorry, there's a plus here, as I said at the beginning. So now we are dealing with ones. We said there is a 1 year. We just learned this. There is a 1 year, and now I'm saying that there is a hidden 1 year, and there is a hidden plus year too. So if the age is standing alone, there is a hidden plus year, there is a hidden big plus year, and then there is an over 1 under, and there is a hidden 1 up here. So I think you should note this. Because sometimes it will be silent. They won't tell you there is a hidden 1 up there. You just have to know. Okay. So the example here, to 1 over a is equal to 1 over a minus, a raised to the power 1, which is equal to a raised to the power negative 1. 1 over 7 raised to the power 2 is the same as 7 raised to the power minus 2. I have a few examples here I would like us to solve. So the first one says we should evaluate each of the following. So we'll just take this two, we'll just evaluate this two. So 3 exponents 5 and 7 exponents 3. So let's just go. So 3 exponents 5, 3 exponents 5, and 7 exponents 3. So evaluating this, meaning we should break it down. So this is 3 times 3 times 3 into 5 places times 3. So we can decide to get our final answer, which is going to be quite huge. So that's 3 times 3, which is 9. 9 times 3, which is 27. 27 times 3, and that's answer by 3. So that will give us, so you can do the calculation yourself. Then 7 exponents 3, that is 7 times 7 times 7, which is 49 times 7. You can do the calculations yourself. Okay. So let's see the next example. The next one, we've been asked to evaluate the following negatives. So this, we'll just take the first two. That's 2 exponents negative 9 and 3 exponents negative 5. So let's move on to our note sheet, and over here, this is no one to avoid confusion. So negative 9. Yeah. So this means we are going to find the reciprocal. So we'll have 1 over 2 raised to the power 9. And this will be 1 over 3 raised to the power 5. As simple as that. Okay, so there is one example I would like us to solve. This is it's a combination of all what we've done. So let's just do this. Then I'll give you a few assignments to do. So that is a raised to the power minus 1 over 3 times a raised to the power minus 1 over 3 times 2a raised to the power minus 1 over 2. So this is a combination of all what we've done so far. So now in solving it, so the first thing we would have to do here is to find ways of eliminating the negative. So in eliminating this negative, we would have 1 over a raised to the power 1 over 3. As simple as that, negative just goes away. And the negative is affecting only the a because it is not in bracket. So this 2 is free. Because it is not in bracket, this 2 is free. So we are going to work on only this a. So we'll be having 2 times 1 over a raised to the power negative. Now the negative goes away. So 1 over 2. So now we have a 1 over a raised to the power 1 over 3, 2 times 1 over a raised to the power 3 over 2. So this can be written as 2 times 1, which is 2. So 2 over a raised to the power 2 over 3. So let me move this to the next page. So we add 1 over a raised to the power 1 over 3 times 2 over a raised to the power, we just confirm that, 1 over 2. Okay. So now this is what we have. So in this case, we can apply our laws of fraction. So this is fraction. We can't cancel. So we'll just multiply the top by the top. So with this we get 2. That's 1 times 2 is 2 over a yeah. So these two are multiplying because they are the same base. So we can multiply. They have the same base. So we would maintain one of the a's and then add the exponent. That's 1 over. So in this case, we'll get 2 over a. So this, we need our LCM, which is 6. 3 goes into 6 2 times. So 2 plus 2 goes into 6 3 times. So this is 2 over a raised to the power 5 over 6. So 2 over a raised to the power 5 over 6. Oh, 2 over a. So which is written as 2 over a raised to the power 5 over 6. Mostly, it's advisable to leave your answer in a linear form, so you just have to rewrite this as 2a negative 5 over 6. So this is our final answer, 2a raised to the power negative 5 over 6. Yeah. So the only way you will understand it is you trying it out yourself. So try it out yourself and then see if you would arrive at this answer. And if you do, bravo. So I'll give you some assignments to try working it out, and then I'll see you in the next lesson. Bye bye.